I am Mr. Gant. Project Management. Schedule Quality Review using DCMA 14 Points Assessment. In this video, we will see the DCMA 14 Points Assessment for reviewing the schedule quality. This is not mandatory to be followed for developing the quality schedule, but it is helpful for us to understand what are the parameters behind the quality schedule. First of all, we have to understand the DCMA 14 points. To understand the 14 points, we can go back to the history of the DCMA 14 points. The DCMA means Defense Contract Management Agency of United States. They have developed a comprehensive approach to run value management known as DCMA, EVMS, but to achieve effective EVM, the quality of the supporting information is critical. That we will discuss in the next video. The quality of the supporting information, especially for the requirements relating to the progress update, EVM can be prone to manipulation, right? And if the undermining data is inherently weak, the whole process is undermined. If I will put 25% progress on the foundation, and nobody knows how I have calculated this 25%. There is no backup, there is no detailed calculation, quantitative calculation. So, it will be very subjective to judge the things that this is legitimate or not, and even the next month. If the scheduler will see some progress loss, he may put more progress on that to hide the fact and visualize the good progress and the performance, but that is not the case. So, there is the main concern to implement the EVM, the supporting information, and also the correct data. The DCMA 14 points analysis is used to check the technical quality of either internal or external schedule, and is widely used around the world in all industry sectors. This is not only for the construction, and not only for the construction and engineering, but it is used widely around the world in all the industry sectors. The key points of DCMA analysis. So the 14 points analysis has a mathematical calculation. The calculation used in DCMA can be performed manually, but it is recommended that a proprietary software is used, so the benefits are not lost in the cost of preparing the analysis, because it is not a one-time calculation. Each time we will update the schedule, we have to check the quality of the schedule. So, it will be time-consuming as well to calculate every time. So, that is why it is better to keep a system. We have the system inside P6 to see the result of the DCMA 14 points. Probably 11 points we can see in P6, 12 points in the 2 points related to critical path is not mentioned in P6. The primary role of the DCMA 14 points analysis is to assess the overall technical structure of the schedule and ensure that the fundamental rules of the schedule development have been followed. That means, as soon as the DCMA 14 points is matched with the schedule, we can call the fundamental rules of the schedule development have been followed. That means the schedule is based on the industrial-based practice. But as I said, this is not the ultimate point to confirm the schedule quality, but this is very useful. The DCMA 14 point assessment metric description will go now one by one for the 14 points. The first one is the logic. So, you have to keep in mind that DCMA 14 points analysis always done on the remaining scope of work, whatever the task finishes, not a matter of analysis. It is the fact we have finished, if it is late, if it is missed. We are not calculating, or we are not analyzing the fact, we are analyzing the probabilities. That means, for the completed task we may calculate, but it is not required. According to DCMA 14 points assessment, the focus is only on the remaining task. So, the logic, this metric looks for incomplete task, means the remaining task that is not finished. Either the task is started, not yet started, or it is in progress mode. This metric looks for incomplete task with missing logic links, or links that do not make sense. The number of tasks without predecessor or successor should not exceed 5%. So, if any task has no predecessor or successor, it will be counted as missing logic. So, out of the total incomplete task that has link or logic, how much is missing? So, the formula is, missing logic percentage is equal to number of missing logic, divided by number of incomplete task. So, total, out of total incomplete task, how much task has no logic, is the result. And if it is 5% or more, that means we are crossing the threshold. And it will not be acceptable if we have to follow the DCMA 14 points for the approval of the schedule. The second thing is the leads. Leads means the gap between two tasks. Leads means the offset between two tasks. This metrics look for incomplete task. In P6, we can put leads by putting the negative lag. So, we call it negative lag as well instead of lead. So, this metric looks for incomplete tasks that have logic links with leads, I mean the negative lag in predecessor relationship. Ideally, there should not be any leads. That means DCMA 14 points assessment. The Institute is also not allowing any leads to the schedule. So, they are not allowing negative lags. Rather, they are encouraging to use the lag, but it should be within the limit as well. The formula is leads percentage equals to the total number of logic links with leads. That means how many tasks has negative lag, divided by the total number of logic links. So, the number of logic links and the number of tasks may not be the same. The lags. As I said, the positive lag. This metric look for incomplete tasks that have lags in the predecessor relationship. So, instead of leads, we may use lag, but it is also limited to 5% as well. If it is more than the 5%, that means we are not meeting the requirement of DCMA 14 points. The formula is similar to the leads. We have to identify first the number of tasks that has logic linked with lags, and then we have to divide it by number of logic links and multiply it by 100% to get hidden percentage. So, if it is more than 5%, that means the schedule cannot be accepted if it is the requirement to approve the schedule. I mean the DCMA 14 points is the requirement. And then, the relationship types. Point 4 is the relationship type. This is important. This metric looks for incomplete tasks. So, everywhere you will see the incomplete tasks containing its relationship type. So, we know that we have 4 relationship types in P6. Finish to start, finish to finish, start to start, start to finish. The preferred relationship is the finish to start, according to the DCMA 14 points, and they are insisting us to maintain at least 90% of the relationship type should be finish to start. The formula to calculate percentage of finish to start relationship is the number of logic links with finish to start relationship type divided by the number of logic links. So, I will explain to you what is number of logic links and what is the number of tasks. Say for example, we have 2 tasks linked with each other. That means they have 2 relationship. One is with predecessor and one is with successor. These 2 tasks has 2 relationship. So, if we will create another 1 task and we will link it with the 2 tasks, then another 2 relationship will be created. That means 2 plus 2 is equal to 4 relationship, but the number of tasks is equal to 3. So, it is not mandatory to have the number of incomplete tasks and the number of logic links to be the same. So, this is different things. The formula for calculating finish to start is the number of logic links with finish to start relationship divided by the total number of logic links multiplied by 100% to get hidden percentage. And then, the hard constraint. When we do not have the proper predecessor of a task, probably, we will use the hard constraint, but it is not unlimited that we can use the hard constraint. It is also limited to 5%, according to DCMA. So, maximum 5% task can be allowed. The formula to calculate the hard constraint percentage is equal to total number of incomplete tasks with hard constraint divided by total number of incomplete tasks. That means, out of X number of incomplete tasks, how many tasks are with hard logic? So, this formula is not related to the logic links, related to the number of tasks having hard constraint and the total number of incomplete tasks. The high float means poor planning. If it is with high float, that means the sequence and the planning is not clear. That is why the task is put in a place without binding with the proper sequence, considering the resource allocation and everything. So, what are the high float point? This metric counts incomplete tasks with total float greater than 44 working days. It is mentioned in the DCMA. So, the 44 working days, mainly for 5-day calendar, and for 7-day calendar, it will be 60 days. This may indicate missing predecessor or successor. The number of tasks with the high float should not exceed 5%. Why they are mentioning this may indicate missing predecessor or successor. It could be the case of having the high float, because as soon as the task without predecessor and successor, it gives us a high float schedule. So, the number of tasks with the high float should not exceed 5%. The threshold, the limit is also here, the 5%. The formula is high float percentage is equal to number of incomplete tasks with high float divided by total number of incomplete tasks into 100%. Then, we will go to the negative float issue. We have discussed about negative lag, but this is negative float. This metric counts incomplete tasks with total float less than 0 working day. This task should have an explanation and corrective action. So, usually we should not submit schedule with negative float. Rather, we have to suggest a mitigation plan and also an EOT request. The formula is negative float percentage is equal to total number of incomplete tasks with negative float divided by total number of incomplete tasks into 100% to get hit at percentage. The high duration, similar to the high float. The requirement is also the same. For the high duration, should not be 44 working days. For the task duration, having a calendar of 5 days work per week, but 60 days is the limit for a 7-day work week calendar. So, we have to keep in mind the 44 working days is based on 5 days work week calendar. The number of tasks with the higher duration should not exceed 5%. So, the limit is also at 5%. The formula is high duration percentage is equal to total number of incomplete tasks with high duration divided by total number of incomplete tasks. So, this is not related to the link logic. This is purely related to the task that is remaining. The invalid dates. This is very reasonable things. We cannot put any invalid dates in the schedule. So, invalid dates means we have task with actual start and finish date after the data date. Or, we have forecast before data date are considered as invalid schedule or invalid task. Then, we will go to the point 10, the resources. What is mentioned here is, except the milestone task, we have to have resource loaded at the all task level. So, there is no limit for this. We should not keep the resource part blank for the non-activities. And for the calculation, the missing resource percentage is equal to the total number of task incomplete task with missing resource divided by total number of incomplete task multiplied by 100 to get it 100%. The missed task or late task, it will not be effective for the baseline schedule, missed task or late task, because it is related to the performance of the schedule. So, this metric identifies tasks that have finished late compared to the baseline. As I said, if it is the baseline schedule, it should not be the case. That means there will be no delay compared to the baseline. So, we do not need this for the baseline. It helps to identify how well the schedule is meeting the baseline plan and is a good check to gauge whether the project will finish on time or not. So, missed task or late task is kind of indication that we are going with as planned, or we are behind the schedule in terms of number of tasks to be executed. So, the number of tasks should not exceed 5%. So, missed task or late task is also limited it to 5% task, and the formula is missed percentage task is equal to total number of tasks with actual or forecast finish date past baseline date. That means, whatever the activity that should have been started or finished before the data date, according to the baseline, divided by number of tasks with baseline finish dates on or before the status date. So, that means if you want to be clear about these things, that for example, we have planned to do 5 tasks for 5 days. At day 3, we have to complete the 3 tasks. If we will complete only 1 task, the remaining is 3. So, we have missed the 3 tasks out of the 5 tasks, and then we have to calculate the percentage. So, this is the calculation. The critical path test is kind of testing the integrity of critical path, whether the critical path is real critical path or the manipulated critical path. This metric checks whether introducing a delay into the schedule results in the project finish date being clearly delayed, because the meaning of this sentence is, if we will delay 5 days for any of the tasks that is in the critical path, it should be delayed by 5 days. For the overall project but it is delaying, or not, that we have to check. If we will delay one critical path task for 5 days, but the project is still the same in terms of finish date, that means something is wrong inside the project. If there is no intermediate milestone, or the contractual milestone, related to the project. If we have some contractual milestone, and an early delivery of some phases, probably we could see some more critical paths than the only one linked with the constraint that is the contractual completion of the phases, or some major deliverables. So, critical path test is important as well. So, this is a test on the critical path to see if there is broken logic when a slip is introduced. So, this is the critical path test to the DCMA 14 points. Then, the critical path length index. So, this is also important, because as soon as we have some buffer in the schedule, we may see the value of CPLI is 1 point, something that means we are doing right. If it is below 1, that means the critical path index, that means we have a negative float probably in this schedule. So, this metric gauges the project can realistically be completed on time, or not. It measures the ratio of the project critical path length, plus the project total float, to the project critical path length. So, if the total project critical path length is 12 days, and project contractual completion date duration is 15 days, that means we have 3 days buffer. So, if we want to calculate the CPLI, then we have to consider that 12 days, plus 3 days is equal to 15 days, divided by current critical path is also the 12 days. As we are maintaining 3 days buffer for the project. So, 15 divided by 12 is more than 1, that means it is good that we have some buffer. Inside that is why it is showing greater than 1. It measures the ratio of the project critical path length, plus the project total float to the project critical path length. This is a measure of, purely of the realism of the critical path. And the last one is, the baseline execution index, as we have explained earlier, in point 11 the missed tasks, the point 14 the baseline execution index is just the reverse of that 11th point. So, in that point, it is mentioned that 5% task should be minimum, 5% task, and could be allowed, in terms of missing task, and in this point number 14, the baseline in the execution index, it is mentioned the limit is 95% task. So, this metric determines how many activities are behind or ahead of schedule against the baseline. The baseline execution index measures task accomplished against task plan for completion. I mean, the plan versus actual, how many tasks has been planned, and how many tasks has been completed. So, this is the main part of this calculation. This test is nearly the reverse of check 11 missed task. Instead looking for under 5% missed, we are looking for over 95% success. So, the summary of the DCMA 14 points analysis. We have seen the 6 points as limit of 5%. I mean, we have to respect the not more than 5% limit for the missing logic, lags, hard constraint, high float, high duration, and missed task. 1 point is target of greater than 90%, that is the finish to start a relationship. 1 point is target of greater than 95% and is related to the task accomplishment in baseline or plan. We call it baseline execution index. And 4 points has zero limit. That means We cannot do these things to develop the quality schedule according to the DCMA 14 points. And the points are leads, negative float, invalid dates, and also the resources. And the 2 points are non-limit related and to test the critical path quality, so we don't have this test in P6. So, this is the DCMA 14 points assessment metric description. Let's see now the tool that is inside schedule report. So, I'll click this option here. By default you see here, we have to change the 3 place value. One is the hard constraint limit here. It is set here 1%, but we have 5% according to DCMA. We have used the 7-day calendar for this schedule, so that means we have to put 7-day, that means 60. This is the 480, here is the 480, I will put it here. Save and check schedule. You will see the result here. The result is here. So all items are here. You can see some additional items, but you cannot see them. The critical path test and the critical path length index and the critical path. DCMA point 12 and 13, you cannot see this one. Critical path test and the critical path length test cannot be seen at the P6 Schedule Quality Review Report. This concludes the DCMA 14 points assessment for reviewing the schedule quality.